In this video, we'll be simplifying expressions that have positive, negative, and zero exponents. Press pause to copy down these rules for exponents. When you're ready to continue, press play. Our first problem that we'll be doing is to simplify this fraction. Now you'll need to notice a few things. First of all, we have negative exponents, and we can use this rule that says that if I have a factor with a negative exponent, then I can write that as 1 over that factor with the positive exponent. Or if it's 1 over x to the negative b, then I can write that as just x to the b. So basically, if it's in the numerator with a negative exponent, you can bring it down to the denominator and make it a positive exponent. Or if it's in the denominator, you can bring it up into the numerator and make the exponent positive. So that's the first step I think that I'm going to use on this problem. So any of the factors, notice that everything's all multiplied. So any of the factors that have negative exponents, I'm going to write those in the other part of the fraction. So this first factor is 5 to the negative 2. So I'm going to move him downstairs, and it's going to be 5 to the positive 2 then, once he's moved. I'll just copy these two. Notice that they have the same base, so I can use this first rule that says if you multiply, you can add your exponents. This is x to the third power multiplied by x to the first power. So that's one exponent there. So that rule then tells us that that's the same as x to the fourth power. And then this last factor in the numerator is y to the negative 2. I'm going to move that factor down to the denominator and write it as y to the positive 2. Right. Now this 5 is to the first power, so I can just write 5. It's not going to get moved. This factor is x to the negative 1, so I'll move that up to the numerator and make it x to the positive 1. And then this y right here is to the first power. I'll just copy that in the denominator. And then this y is to the negative 3. I'll move that up to the numerator and make it y to the positive 3. Now there are different ways to attack these kinds of problems. This is just one way, the moving up and down. Alright, now I see that I have x to the fourth times x to the first, so I'll use this first rule that says I can add those exponents together. So these two factors, when I put them together, it becomes x to the fifth power. And then I'll just copy this y to the third power. Now this 5 to the second power and this 5 to the first power, that's the same as 5 to the third power. And then this y squared and this y to the first, I can add those exponents using that rule, and that becomes y to the third power. Right, some things that I notice is that I have a factor in the numerator that's the same as a factor in the denominator. And so when you have factors, in other words multiplying, and they're the same, you can cancel because y cubed over y cubed is equal to 1. So then this fraction simplifies to x to the fifth over, and then 5 cubed. We know 5 times 5 times 5. is 125. Let's do another problem. Now this problem is a little bit different from the previous problem in that I have addition and subtraction as well as multiplication, and then I also have some negative exponents. So let's see, my first step, I'm going to combine a few things. I'm going to go ahead and add my two terms that are in the parentheses right here. So I have the negative that's on the outside of the parentheses, and then negative 2 subtract 5 is negative 7. And then I also know from my order of operations that I multiply before adding. So I need to multiply these two factors before I can do any addition. So 3 multiplied by negative 2 is a negative 6. So I have a negative 6 there. And then on this one, I have a negative exponent, so I'm going to move this entire factor up to the numerator, and that's negative 3 to the second power. Notice that you don't put parentheses because this negative 2 is only attached to the 3. It's not attached to the negative 3. So when we do square, we're only going to be squaring the 3, not the negative 3. All right, let me copy this minus. And then this last term, we have a negative exponent, so I'll make it 1 over. And this time, my negative 3 is being raised to the power. So I need parentheses there, and my exponent is 2 now, since I moved it down to the denominator. Alright, so now this minus minus, I can make that a positive 7, and I'll write that just as 7. Plus a negative, I can write that with a negative sign. You simplify by just writing one sign, either plus or minus. So again, here I have plus and minus, so I can write minus, and that negative is not with the 3. It's only the 3 that's being squared, so we have a 9 there. And then this minus I'll copy, and here I'm squaring the negative 3. So negative 3 times negative 3 is 9. So this is 1/9. 7 minus 6 minus 9 is a negative 8. And that then is a negative 8 and 1/9. Or we could write that as a negative 73 over 9. Let's do another one. We're asked to simplify by adding like terms. So what we want to do is simplify each of these so that we don't have any negative exponents, and all the factors are simplified as far as possible. So if I move this x to the negative 2, if I move this factor down to the denominator, I'll have a 1 in the numerator, and then I'll have x squared, and then the x and the y that are all multiplied in the denominator, minus. I have a 5 in the numerator here, and I'm going to think of this as canceling. I have two x factors in the numerator that can cancel two of the x factors in the denominator, and that'll leave me with 3 x factors in the denominator. So I'll have x cubed, and then this one I have 1 y factor in the denominator. I'll cancel that with one of these, and I'll have y squared in the numerator. And then the last term, my 4 stays up in the numerator, and I can move this down and have x cubed y. Now these factors are x cubed y, so I can rewrite this term as 1 over x cubed y minus 5 y squared over x cubed plus 4 over x cubed y. Now the directions just says to add like terms, and I can see that this first term is a 1 over x cubed y term, and this last one is also a 4 over x cubed y. So if I put those together, 1 and plus 4, that's the same as 5 over x cubed y. And then this term I have to leave by itself, so minus 5 y squared over x cubed.